Hello to everyone. Welcome back to my YouTube channel. This is Shubham, and we are going to learn about permutation and combination. This is the second lecture. I hope you have gone through the first video of this, where I have introduced what you mean by permutation and combination. Okay, the basic difference between these two things. All right. So let me do a quick recap of what we have learned in the previous video, and then we'll go ahead with, you know, today's session, which is based on counting principles. Okay, so let's begin with the prerequisites, what and all we have done. So in the previous video, we have learned about permutation and we have learned about combination. So when the scenario or the particular question belongs to permutation, what are the keywords? When the order does matter, okay, and combination when order does not matter, right? Selection of certain things or arrangement of certain things. So we talked about the keywords. So arrangement is the keyword for permutation and selection is the keyword for combination. So these things we have seen. Then we talked about the formula, which is NPR for permutation, which stands for n factorial over n minus r factorial. And we had seen the formula for combination, which is NCR, which stands for n factorial over n minus r factorial multiplied by r factorial. All right. Then we had seen about the keywords, right? Some of the questions which can be directly answered just by looking at these keywords, which are arrangement and selection. Okay, selection of a group of people or a selection of a committee, a selection of a team or arrangement of certain things on a line or so on and so forth. Okay, so the bottom line is basically read the question carefully and check for the keywords and analyze it. So if order matters, the question is on permutation, and if the order does not matter, the question is on combination. Okay, now today we are going to talk about when you're not able to guess just by reading the question. Okay, you're not able to figure out whether the question belongs to permutation or combination. So before we move ahead, we have to just check what are factorials. So keywords we had studied. Now moving on to factorials. Just a quick recap and then we'll begin with today's session. So factorial function we had seen, it was denoted by n factorial exclamation sign. So this stands for n multiplied by n minus 1 multiplied by n minus 2 and so on and so forth until unless we get 1. Okay, so similarly we had seen what is 5 factorial. It stands for 5 times 4 times 3 times 2 times 1. So that is 5 factorial. Now, in some of the text, you will see that 0 factorial is equal to 1. Okay, 1 factorial is 1. Also, 0 factorial is also equal to 1. So let me quickly talk about, not exactly in detail, but give you an insight on why 0 factorial is 1, right? So basically, you can think of an intuition or general formula. Can I write 3 factorial as 4 factorial over 4? Right? Yes, because 4 factorial is basically 4 times 3 times 2 times 1 over 4. So 4 and 4 cancels out. 3 times 2 times 1 is basically 3 factorial. Similarly, I could write 2 factorial as 3 factorial over 3. Similarly, 1 factorial can be written as 2 factorial over 2. And following the same analogy, I could say 0 factorial could be written as 1 factorial over 1, which is nothing but 1 over 1. And therefore, 0 factorial is equal to 1. So this is one of the proofs. Now, if I talk about the geometrical meaning of this factorial function, right? So factorial basically represents, if I talk about the geometrical meaning of it, it tells us, right, the number of ways certain object can be arranged on a number line, on a straight line, basically. Okay. So arrangement on a straight line. On a straight line. That is given by this formula called as n factorial. Okay, so if there is a straight line, let's say here, and I have to represent nothing, so isn't this just the one way to draw an empty line? Right, an empty line just like this. So there is only one way, an empty line to represent 0 factorial. Yes or no? And if you go by this formula of n factorial, using that also you could prove it, which says since n factorial is equal to n times n minus 1 factorial, right? In general, in terms of n, I'm saying. So now, if I keep, n is equal to 1, if I put n equal to 1 here, so my LHS will become 1 factorial, and here it will become 1 times 1 minus 1, which is 0 factorial. So 1 times anything is what? The number remains same. So right hand side is 0 factorial, and we know that LHS 1 factorial is 1. So we could prove it this way as well. Okay, so that is the reason 0 factorial is equal to 1. I hope the geometrical meaning of this thing is clear. Okay, now coming on to today's objective of the class, which is basically when the keywords are not there, then how do we know what concept we have to apply? So today's concept, what we're going to learn is basic counting principle. Basic counting principle. Try to understand this. This is the crux of permutation and combination. Once you're very good with basic, this topic will not haunt you. Okay, so I hope you are with me. So let's begin. So basic principle of counting. What exactly is this? So let's try to understand this with a scenario of, let's say there are 3 cities, A, B, and C, and they're connected by roads, something like this. And then from B to C, it is this, right? So there are 3 roads, basically. 1, 2, 3 from A to B. And there are 2 roads, 1 and 2 from B to C. Okay, so A, B, C, these are the 3 cities, and they're connected by 3 roads and followed by 2 roads. Okay, so if I ask you, how many ways are there in which you can go from A to C? In how many ways can you go from A to C? Okay, so now listen to me very careful. And here the keywords which I'm going to use are very, very important. So be careful. I'm saying I can go from A to B either this way or this way or this way. Okay, so in order to complete my action, which is from A to C, how I have divided this, what is the first thing I'm going to do? I'm going from A to B. And to do that, I have 3 ways. Yes or no? There are 3 roads basically. These are basically roads. These are roads which are connecting these cities. So from A to B, there are 3 ways, right? I cannot directly go from A to C. So now the second scenario is, and then I'm going from B to C. So how many ways are there in which I can go from B to C? So there are 2 ways, isn't it? So if you have heard me carefully, listen to me very carefully. I'm saying I'm going from A to B, right, in 3 ways, either this or this or this, right? So I'm using these terms or. Whenever or is there, be careful, that means plus. And then from B to C, right? First A to B and then B to C. So whenever and is there, you have to multiply. Okay, so what is the complete action we have from this scenario? That is, I need to commute from city A to C and I need to go via B, right? So I can go in how many ways from A to B? 3 ways, isn't it? And then I have to commute to C. So how many ways are there? 1, 2. Getting it? So this complete action, which is from A to C, can be clubbed as there are 3 ways from A to B, and then there are 2 ways, right? So and is there, so I'll multiply. Therefore, there are total 6 ways in which I can go from city A to C. So these are the catch which you need to remember. So cram it as it is. Very, very important. Or means plus and stands for multiplication. Okay, so whenever we have a complete action, so the action was over here to commute from A to C, right? So we have broken down this complete action into substandards, or you could say, small actions, which is from A to B and then from B to C. I hope I'm making sense here. Now, let's consider one more scenario. Let's take one more city is there from C to D. So from A to B, I have three roads, so three ways. And then B to C, I have two ways. And then again from C to D, I have three ways. Okay. So now how many ways are there in which I can go from A to D, right? So I can see here clearly that there are three ways, and then B to C, and then, so listen to me carefully, and I'm using, so multiplied by 2, okay? And then C to D, it's 3. So 3 times 2 times 3 is basically your 18. So there are total 18 ways. Okay. And then when you are choosing from A to B, you can either choose route 1, or you could choose route 2, or you could choose route 3. So I'm using or. So or signifies plus, and stands for multiplication. Okay. I hope this concept is clear. And then all. Now, let me talk about one example. Let me put it this way. Consider there is an examination. All right. And in this examination, there are basically 4 questions, which are of, true false category. What I'm saying, in an examination, there are 4 questions total, which are of true and false category, right? So the question is, in how many ways, right? In how many different ways, or I'm saying basically, the keywords are not mentioned. So let me put it this way. How many different sequence of answers are possible? So question is, how many different sequences of answers are possible? What do I mean by this is, let's suppose 10 to 20 students are writing this exam. So 20 students can mark these 4 questions in how many different ways? So one of the possibility could be one child could mark all the 4 questions as true, 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 true. Okay. Or the first one is false, then followed by true and true. Or he could have marked it as true, 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 first 3 as true, and the fourth one as false. So like this, how many such possible answers are there, right? So how do we answer this? So here comes the concept of, as you can see clearly in this question, there is no way the keyword mentioned, right? Which is arrangement or, selection. So can you say, first I'll draw here lines, spaces, very, very important. So these spaces basically represent your 4 questions. So now think logically. Okay. First question can be answered in how many ways? Either true or false. Yes or no? So 2 ways. And then the second question. First, you will mark the first question. And then, so I'm using and, so multiplication. Then again, you can mark this in 2 ways. That is true and false, which is again 2. And then true and false. And then true and false. Right? So you just multiply all this together. So you basically get how much? 16. So 16 is the correct answer. Okay. Similarly, you can extend this analogy to find the total number of sample space when you toss a coin. Okay. Another scenario, tossing of a coin. Tossing of a coin 5 times. So how many sample spaces we will get? The outcomes. How many outcomes will be there? So 5 times means 5 spaces, right? And every time you can get the outcome as head or tail, head or tail, head or tail, head or tail, and head or tail. So right, in first toss, you can get either of the two, and then second toss, and then second toss, and then second toss. Let me write it properly. And then the fifth toss. So which is nothing but basically 2 to the power 5. which is 32. Okay. So this is what basic principle of counting tells us. Now, since we have studied and we got a pretty much good idea about how to use basic principle of counting, the use of or and. So in the next video, we'll be continuing with the different, categories of questions which are asked in exam. So until then, stay tuned, do share with your friends, and thanks for watching.